Welcome to the Deep Dive, where we extract the critical nuggets from the most definitive source material so you can be instantly well-informed. Our mission today is foundational. We are launching a deep dive into JavaScript, using David Flanagan's massive JavaScript, the definitive guide, as our primary intelligence stack.
And this is so essential not just for history buffs. I mean, JavaScript is arguably the most deployed and most used programming language on the planet.
Yeah.
But really mastering it means you have to understand its surprising foundations, the historical quirks, the data types, and especially the new ES 2020 features that fundamentally change how we write safe code.
Exactly. We've synthesized a huge stack of material here. We're talking core language structure, types, variables, operators. The goal for you, listening, is a thorough, accelerated shortcut to understanding the absolute fundamentals of modern JS development. It gives you the why behind the code you write every day. Okay, so let's just dive right in and unpack JavaScript's identity crisis. It's famous for having one of the most confusing names in tech. It was created at Netscape, sure, but JavaScript is technically a trademark. So what are we actually supposed to call it?
That's a great question. The standard, the formal name is ECMAScript, usually shortened to ES. Flanagan is very precise about this. He'll say ES5, ES6, ES 2020 to refer to the standard. But in practice, you're right, everyone just calls it JavaScript. The names are basically interchangeable now.
So knowing ECMAScript as the spec helps when you're looking things up, and it's a language that really feels like a bit of a Frankenstein's monster, you know, in a good way. It's often mistaken for being related to Java because of the name.
That was a pure marketing decision. The syntax has that C-style curly brace look, so you can see the confusion. But what's fascinating is where its core ideas actually come from. It's first-class functions, the ability to treat functions like any other variable. That's straight out of Lisp and Scheme.
Right. And its inheritance model is even more unique.
Oh, completely. It's prototype-based, which it gets from a much lesser-known language called Self.
Okay, so let's unpack that for a developer who comes from, say, a C++ or Java background. How does prototype-based inheritance change how you should think about objects?
It's a fundamental mind shift. In classical inheritance, you have a class, which is a blueprint for objects. In JavaScript's core model, objects don't inherit from classes. They inherit directly from other objects. So you don't ask, what class is this? You ask, what object is this prototype?
Even with the new class keyword.
Yep, that's just like syntactic sugar. It looks familiar, but underneath, it's still that same prototype mechanism. It's what makes JS so flexible, but also so surprising.
And its dominance today is all about the environments it runs in. It used to be just the browser.
That's right. The original home was the web browser, making web pages interactive by talking to the DOM, HTML, and CSS. But then Node.js came along in, 2010, and it just blew the doors off everything. Suddenly, JS could run on the server. It had access to the file system, to networking, everything. It went from a scripting toy to a full-stack engineering tool.
But as it grew up, everyone realized some of those early design decisions were, let's be honest, a little flawed. How did they fix those without breaking the web?
With a really clever mechanism called strict mode, which started in ES5. It's basically an opt-in. You put one line at the top of your file, and you get a corrected, safer version of the language.
What does it actually do?
It turns silent errors into thrown exceptions. So instead of your code just misbehaving in a weird way, it actually throws an error and stops. It forces you to write cleaner code.
And for modern development, you often get this for free, right?
You do. If you use ES6 modules, or the class keyword, strict mode is often turned on for you automatically. So new code is just held to a higher standard by default. But, okay, that's behavior. Let's talk about the data itself, which has its own rigid rules, starting with the biggest split: primitive versus object.
Yes, this is the division that really separates the pros from the novices. Every single value in JavaScript is one or the other.
Understanding this is absolutely critical. It controls how data is stored, how it's compared, and whether you can even change it. Mutability.
Let's start with the primitives. We've got number, string, Boolean, symbol, and then the special ones, null and undefined.
And the most important thing to know about primitives is that they are immutable. You cannot change them. If you have a string and you try to change one letter, you can't. What JavaScript does is it creates a whole new string for you.
So calling a method like to uppercase doesn't change the original string.
Never. It gives you a new string back. And this is a good thing. It's for performance and security. And, critically, primitives are always compared by their value.
And then on the other side, we have objects. Arrays, functions, regular objects, they're the complete opposite.
Totally. They are immutable. You can change their properties after they're created. And this is the concept that trips everyone up. Objects are compared by reference.
Okay, we have to nail that reference concept down. It's the source of so many bugs.
It really is. So imagine you have an object, let user A equals name, Alice.
Right.
Then you write, let user B, user A. You haven't made a copy.
No, you've just made another label that points to the same object.
Exactly. Both variables point to that one single object in memory.
Oh.
So if you change user B name to Betty,
Then user A.name is also Betty.
you got it. And if you ask user A is user B, the answer is true. They're the same thing.
Okay, let's get into the really weird stuff, the numeric oddities, the whole IEE 754 floating point standard.
Ah, yes. The classic gotcha moment. JavaScript uses 64-bit floating point for all numbers, which means it's often approximating. The problem is that computers think in binary, and just like 1/3 can't be perfectly represented in decimal, a lot of simple decimals can't be perfectly represented in binary.
So when you type 0.1 plus 0.2, you're not actually getting a perfect 0.3.
You're getting a very, very close binary approximation of it, which is fine until you try to compare it for strict equality. That's when the tiny imprecision shows up, and 0.1 plus 0.2 equals 0.3 returns false.
A huge trap. And if that wasn't weird enough, we have the special value nan.
Nan, not a number.
Mm-hmm.
You get it from things like 0, 0, 0. And here's the classic quiz question. Nan is not equal to anything,
Including itself.
including itself. If you type nan into the console, it is false.
Wow. Okay, so if I want to check if a variable x is nan, just doing x and nan is always going to fail.
Always. You have to use the check x, which is only ever true for nan, or the much cleaner way, the built-in number to isdan annex.
Now, a modern fix for some number problems is bigint, right? This was for dealing with huge integers that floats couldn't handle.
Absolutely. Bigint came in with ES 2020. It allows for arbitrary precision integers so they can be as big as you need. This was huge for crypto, finance, anywhere you have massive numbers like transaction IDs where you can't afford to lose any precision.
But there's a big rule about using it, a hard line.
A very hard line. You cannot mix bigint and regular number types in the same math operation. If you try, it throws an error. The engine won't guess which type you want and risk losing data. You have to explicitly convert them first.
Okay, and just to round this section out, strings. They're immutable, 16-bit values. But the big quality of life improvement has been template literals.
Oh, for sure. Using backticks instead of single or double quotes
Yeah.
cleaned up so much code. Multi-line strings are suddenly easy, and expression interpolation, the expression syntax, it makes building complex strings so much more readable. And, if you want to see just how much the language has matured, you just have to look at how we declare variables. For years, it was just var.
And now var is basically a code smell. We've moved on completely to let and const. The difference is all about scope. What was the big problem with var?
Var is function scoped.
Mm-hmm.
That means a variable declared anywhere inside a function is available everywhere inside that function, but the real killer was hoisting.
Ah, hoisting,
Yeah.
where the declaration gets secretly moved to the top of the scope?
Right. The declaration is lifted, but the assignment, the part with the equal sign, stays where it is. So if you try to use the variable before you define it, you don't get an error.
You get undefined.
You get undefined, and your program just keeps going with this weird, unexpected value. I remember losing half a day once to a loop counter in an async function that wasn't behaving right because of var hoisting. It's a silent, subtle bug.
And let and const fix this by being block scoped, which is what most programmers expect anyway.
Exactly. They are scoped to the nearest set of curly braces. And if, block, a for loop. And if you try to use them before they're declared, you get a hard reference error. The program stops, which is so much better.
And people really prefer const over let for almost everything, even things that aren't, physical constants. Why is that?
It's all about communicating intent. If a value isn't supposed to be reassigned, declaring it with const makes that clear. It's a safety barrier. If you accidentally try to change it later, the engine will stop you with an error.
Moving to syntax, let's talk about destructuring. ES6 introduced this, and it's fantastic.
Destructuring is such a huge win for readability. It's where the left side of an assignment just mimics the structure of the data on the right. So you can pull values out of arrays or objects all in one line.
I love it for swapping variables. It used to take 3 lines and a temp variable. Now it's just x, y, equals y, x. That is so clean. But wait, how does that actually work under the hood? Is the engine making a temporary variable somewhere?
That's a great question. It's basically syntactic sugar, but it's very clever. The engine evaluates the right-hand side first. So it creates a temporary intermediate array with the current values of y and x. Then it immediately unpacks that temporary array and assigns its values to the variables on the left. It all happens as one atomic operation.
So it's efficient and clean. And you can do the same with objects to pull out specific functions from libraries,
Oh,
right?
all the time. If you're doing a bunch of math, you can just write const sin, cost math.
Yeah.
Now you can just call sin directly instead of math.sin every single time. It's a huge quality of life improvement.
All right, let's talk about the new safety nets from ES 2020. Specifically, how they solve the problem of falsy values. There are 6 of them: false, null, undefined, zero, the empty string, and nan. And the fact they all act like false in a Boolean check causes so many headaches with default values.
It's a real nightmare, yeah. For years, we used the logical OR operator to set defaults, like let timeout equals user timeout 1000. And that worked fine if user timeout was null or undefined, but it fell apart if a valid setting was 0.
Right, because 0 is falsy, so the operator would see it as not a value and skip right over it to the default of 1000.
Exactly. The user explicitly set the timeout to 0, but your code ignores it. That's a guaranteed bug. A frustrating one.
And this is where ES 2020 gave us the nullish coalescing operator, the double question mark.
The operator is such an elegant solution. Unlike day, which looks for the first truthy value, is much more specific. It only moves to the second operand if the first one is strictly null or undefined.
So if the value is 0 or an empty string, sees that as a perfectly valid intentional value and keeps it.
It keeps it. So our example becomes let timeout, user timeout 1000. Now if the user sets 0, the timeout is 0. It just works the way you'd expect. It makes the code so much more reliable.
Okay, and the other huge safety net was the conditional property access operator, the ACI. I mean, we've all written that ugly chain of if A and AB and ABC just to safely access a deeply nested property. How does AGIC get rid of that?
This is pure defensive coding in just a couple of characters. Before, if you tried to read, say, customer.address.city and address was null, your whole app would crash with a type error. The app check or optional chaining prevents that crash.
How? What's the mechanism?
The key word is short-circuiting. As the expression is evaluated from left to right, if anything to the left of a BAP is null or undefined, the whole expression just stops right there. It immediately returns undefined, and crucially, it doesn't even try to evaluate the rest of the chain.
Yeah.
So no side effects happen. It just fails silently and safely.
And this works for calling functions, too.
Absolutely. If you write IOM, you're saying, hey, if OM exists and it's a function, call it. Otherwise, don't worry about it.
Okay.
If the method is missing, the call is just skipped, and the whole thing returns undefined. It is revolutionary for writing robust code that deals with APIs or data that might sometimes be incomplete.
We've covered some really intense ground today. We went from the philosophical identity of JavaScript, its roots in scheme and self, all the way to the critical split between mutable objects and immutable primitives. We detailed those numeric traps like NaN and why BigInt became necessary, and then we saw how ES 2020 gave us these amazing safety tools like NAD to write better code.
You know, the one thread that runs through all of this is that JavaScript is fundamentally defined by its liberal type conversion. Coercion, the famous example, 10 plus objects, just works. It becomes the string 10 objects. And while that flexibility allows for some powerful idioms, it demands that you, the developer, are constantly vigilant about types and equality. It's a double-edged sword.
That vigilance is really the core of JavaScript mastery. We all agree that the strict equality operator is the one you should always use to avoid that confusing type conversion. But here's a final thought I'll leave you with. Even though the gold standard, what specific non-obvious programming scenarios might still make you reach for the loose equality operator? Until next time.